Hey guys, it's Sam for Digital Meat, and in this tutorial we're going to be looking at the PBR workflow in Cinema 4D and also the ProRender GPU render engine. I'll warn you now, this is probably going to be a long one, so I'll try to put timestamps in the description of the video. So this is just a scene that I've set up, nothing special really. I've got a camera in the corner and it's just a room with some objects in it really. So, you know, nothing to write home about. But this is going to be the basis of all the stuff we're going to go through. So let's get back into our camera view. So first I want to talk a little bit about PBR workflow and what that actually means. PBR stands for physically based rendering. Because this workflow uses physical properties of materials and lights to achieve a realistic look and feel, it's a common misconception that you can just slap a PBR material or shader on an object and things will just look correct. This is wrong, and it is not what PBR is. PBR is a multifaceted workflow. Not only does our material need to be correct, but our lighting model, color space, and light settings need to be correct too. Another tip, scale is important. If your model, say a cup, is 20 centimeters tall in reality, then model it 20 centimeters tall. There is no use having a cup 20 meters tall. It won't look right, and it may cause problems with ProRender that we'll go into later. Also, it'll have an effect on things like depth of field in your camera. It just won't look right. So the first thing I want to talk about is linear color space. Here's two screenshots I took from a scene in the Unity game engine. The materials for both scenes are physically based, but the image to the left, this one here, is using a gamma color space, and the image to the right is using a linear color space. Notice how in the right image there is a more harmonious dispersion of light and the scene appears to be brighter overall. This is because the math is correct. So, you know, we're getting some proper dark areas here. Also, the reflections are really noticeable on this. Ignore the, you know, whether the reflections are correct or not. I was using a reflection probe in this scene, so ignore the reflections themselves, but notice how the energy coming off the floor in the right image looks way more correct than it does in this image. And notice the sort of light seems to be traveling further in the right image as well, whereas this is a bit sort of more washed out. This is because the math is correct in the right image, which makes linear color space a hard requirement for a PBR workflow. Other advantages of a linear workflow are overexposed regions will be reduced and you'll get more natural colorization. This is why whenever I work in Unity using the PBR shader, the first thing I do is go to the player settings and turn on linear color space. Now let's talk about this in Cinema 4D. In Cinema 4D, linear workflow is not something we have to worry about actually, because if we go to our document settings here, I think you can get to it by pressing, let's go somewhere else, Control D, yeah. Okay, you'll notice at the bottom here, linear workflow is already checked on. Linear workflow has been part of Cinema 4D for many years and is switched on by default. So, you know, you can see that here. It's not something you're going to have to worry about in C4D. Okay, so let's start with materials. In C4D R19, which is what I'm using, we have a new material preset called the PBR material. If you're using an older version like R18 or R17, you will not have this preset, but you can actually just create it yourself. So I'll talk about that in a minute. So if I go down to the material thing here, usually I'll just double click in here and create a material, but that is not what we're going to be doing. We're going to be creating a PBR material. So if I go to create, new PBR material, it creates this. Let's open it up. Okay, so the first thing you'll notice is that only the reflectance channel is active. This is because in a PBR material, what would normally go in the color channel here is now handled inside of the reflectance channel. This may seem strange, but it is in actuality physically correct. So let me just grab another image. Consider this brick. It could be described as matte or not reflective, but it is. The very fact that we can see it shows that it is reflective. Light rays come in from a light source. The light rays hit the brick. Some energy is lost by absorption. And then the light is bounced into our eyes, or in this case, the camera lens. So we can see and perceive its colour. So even matte objects are reflective. It's just that these reflections are highly diffused. Another property of a PBR material is energy conservation. In general terms, it means that the amount of reflective light from an object surface, so in this case our brick, we have light coming in, it hits the surface, and the amount of that reflective light that gets to our eye will not exceed the amount that came in initially. This means that when we create a material, a PBR material, it will look correct under any type of lighting condition. Okay, so let's get rid of this picture and actually have a look at our material. So our by default, the PBR material reflectance channel has 2 layers. So let's click on that, and here we can see what our reflectance channel looks like. So I'm just going to open this up a little bit. So you'll notice at the top here, we've got layers and default diffuse chosen at the moment. So let's just select layers, right? So you can see that we've got 2 layers already in there, a default diffuse and a default reflection. So let's have a look at the default diffuse first. You'll notice that under type here, it says Lambertian diffuse. This will give us matte reflections. So this is basically the new color channel. Instead of being here, it is now in this layer called default diffuse, and this is set to a Lambertian diffuse. In layer color, so here we have a color picker, exactly like we do in our color channel, and we also have a texture slot, exactly like we do in our color channel. And this is what is replacing these inputs here, the color and this. So like I said, this default diffuse is our new color channel. It will handle all of that stuff. In our default reflection layer up here, the type is set to Beckmann here. So this is kind of like a glossy reflection. Beckmann is physically correct and should be the preferred method for normal use. We also have controls for roughness, so we can choose, at 0% roughness, this will be 100% glossy, 100% shiny, and then obviously as we turn this up, the surface of our reflected reflection channel, even our default reflection, becomes more rough. So I'm just going to whack this back down to 30. So we've got controls for roughness, and we've also got reflection strength as well, so we can turn that down. And you can see that it still looks like it's reflecting there, and that's because of this specular strength. If I turn that all the way down, there won't be any, but if I turn this up now, we can see that our reflection's coming back. Just a quick note, specular strength is kind of like a fake reflection, if you like. It's like an approximate reflection. So, if you want, you can turn this all the way down. I'm just going to leave it as it was for now, because when we render, you're not going to see this anyway, because it's all based on reflections. Okay, and obviously we've got a bump strength, and if we twirl this down, same for any of these, by the way. So if we turn this down, we can actually define roughness with a texture if we wanted to. And the same for these, we can define specular strength with the texture, also reflection strength, and also bump strength. So for instance, in roughness, if I had a black and white texture in here, so it was checkerboards, where it would be black, it wouldn't be very rough, and where it was 100% white, that would be 100% roughness. So you can actually define these values with textures. In terms of the layers here, we've got default diffuse and default reflection, but we can actually add layers. And I think, so let me add another Beckmann on top. And then in this layer, I can say, okay, well, this is a Beckmann. Its layer Fresnel is dielectric, and this one's going to be really rough. So if I change the order of this, you can see that underneath we've got our really rough layer, and then on top of that we've got a glossy layer. So it's almost like sort of building up layers of lacquer. I've got a lacquer layer on top of this really rough layer. So you're just sort of building up layers like you would if you were painting something in real life. You do an undercoat, then you put a paint on top, then you might put some kind of lacquer on top. So it's it's a lot like that. In fact, this is a lot like Photoshop, because you can stack layers one on top of another. So I'm just going to Control Z, just undo what I did, so we're back to what we had before. Okay. So like I said, if you're working with older versions of Cinema 4D, let's just name our material here, PBR, so I don't get confused between the two. If you're using like R18 or R17, you're not going to have this PBR material, but we can create it. So you just create a material like normal. Let's open that up. And in the color, we just turn that off. In reflectance, let's remove all of this. And then we'll add a layer. And if you remember, our default diffuse layer was a Lambertian diffuse. So let's do that. And you can name this layer default diffuse. And we've got it set to Lambertian. And then we can add another layer and make it a Beckman, like our default reflection. And I think it's, for now, was a dielectric, and I think it had a PET or something like that on it. Turn our roughness up to 30%, and you know that matches our other materials. So you can actually create your PBR material yourself from scratch. So it's not really a problem. Okay, so let's get rid of that. So let's just apply this PBR material to our objects in our room. I'm going to apply it to everything. I went the long way round to do that, but okay, so we've got all our materials on objects in this room now. So let's just hit render and see what we get. Well, that looks pretty awful. Lots of grain, terrible lighting. And the lighting itself, actually, that's because our scene is currently being lit by the default light. The default light is on automatically until an actual light is added to our scene. So you can find the default light here. If I go to our render settings, currently in standard render, but if I go down to options, you'll see that we've got this default light checked on. Now, if I turn that off and render, you'd get what you'd expect to see in a scene with no lights, pitch black. But I'm going to turn the default light back on. I think basically this default light, it gets overridden when you actually add a light to the scene. Okay, like I said, I'm currently in standard render. So let's go to our render settings. I'm actually going to switch my render method over to physical render because I prefer the level of control that I get from one place in the render settings. So I'm in ProRender there, physical, that's what I want. So now we're in physical render. If I go down to physical, I can control, you know, a lot of the stuff with the samples here. It's at this point I should probably note that a PBR workflow can be used with standard and physical render, but it will be slower than using a normal workflow, i.e., you know, the normal color channel in your material and maybe add in some GI. So you've been warned, your render times will increase if you're using a PBR workflow with either the standard or physical render. A PBR workflow in Cinema 4D really has been tailored towards use with ProRender. So let's get a physically correct light in our scene. So let's close this. We're in physical render at the moment. Let's get a physically correct light. We have a new light type in Cinema 4D R19 called the PBR light. So if I actually drop this down, you can see here we've got this PBR light. So let's just drop that in our scene for the moment and pull it out the way. By default, it has several properties that are enabled that make this light physically correct. It's shadow type, so let's click on the light and go to its attributes. Its shadow type is set to area, and its fall off, which I think is in details, there we go, is set to inverse square, which is physically accurate, you can see there in brackets. So inverse square fall off of light is just like real light behaves. Now again, if you're using an older version of Cinema 4D, you won't have a PBR light as an option, but you can create one by creating an area light. So let's get rid of our PBR light just for a moment. So let's create an area light. Let's go to general and say that the shadow type is area. And in details, we'll change the fall off to inverse square physically accurate, not inverse square clamped. And we can also go to our photometric intensity and turn that on. And by default, the PBR light's photometric intensity is set to, I think, 5000. So there you go. We now have a light that is exactly the same settings as we've got this preset here, this PBR light. So you can create one yourself using an area light. Okay, so now that's out the way, let's set up some PBR lights at our windows here. So I'm going to go grab this PBR light. Great. I'm going to come out of my camera actually, and I'm going to set it up at the holes in our room. So I'm just going to drag this up, and obviously it needs to be pointing in the right direction as well. It's usually in the Z direction. Well, in fact, it's always in the Z direction. So let's turn this around. There we go. And I'm just going to hold shift so I can clip to a 90-degree angle. I'm going to go to my side view as well, so I can actually bring this light down to somewhere like that. There we go. So we can see that it's actually sort of near our opening there. And then I'm going to go into my top view and just make sure that its dimensions cover, the hole in the top of the roof there. Okay, great. Okay, so let's create another PBR light. In fact, I'm going to rename this light so we know which one's which. I'm going to call this top light. Great. So let's grab another PBR light. I know it looks blown out in the scene at the moment, but don't worry too much about that. We're going to fix it. So I'm going to put that there. Get my rotate tool. I'm going to drag this round so it's facing in, and obviously holding shift so we can get a nice... make sure that it's exactly 180 degrees. And again, I'm going to go into my side view, this one this time, and I'm going to grab my window, our light, make sure that its height is big enough to cover the window hole, and then I'm going to go into my top view and make sure that it's wide enough as well. So there we go. And then I'm going to copy this, so control, drag out our light, and then set it up at the other window as well. So I'm just going to rotate it so it's facing the right way. Then I'm going to put this at this window here, and I think we need to adjust it slightly so it covers our window. There we go. And I'm just going to go into the side view just to make sure it actually covers our window in height as well, and it does. Okay, so that should be our light setup, and like I said, I realise that it is very overblown. So if we go to the general settings of one of our lights, we can see that its intensity is 100%. So let's select all three lights and drop all of their intensities down to 30%, something a little bit more manageable. Okay, so we've got one PBR material that's just on everything, and that isn't very interesting really. So I'm actually going to rename this PBR material to room. There we go. And then I am going to control drag out this material, so we've got a copy of it, which is room 1. And I'm going to just create some materials to put on our different objects, just to make this scene look a little bit more interesting. Let's make some shiny materials. I'm going to call this teal. Okay, and then in the reflectance channel, in the default diffuse, I'm going to change its color to, let's go to RGB, and then I can put in an actual hex value. This is the color of my Digital Meat logo. And then in the default reflection, I'm just going to actually take off the specular strength. That's kind of annoying me. And I'm going to bring this roughness down as well. I want this to be quite glossy, so maybe sort of 5% roughness. Not much. And this can go on our main object in the scene, this bad boy. So now all I have to do is drag this out. I can rename this as well. So let's call this red. And then again, go into our default diffuse. I'm just going to change this to red. Like that. Something maybe a little bit darker than that. Yep, that'll do. And I'm going to apply this to our balls here. And then one last colour. Let's make a weird green or something. Yeah, let's call this green. And something like this. This will do, won't it? Okay, cool. So we've got a green colour, and we can put that on our little tube. Now I'm just going to delete the white materials off of the ones that we don't need it on anymore. Not because it'll have an effect, but because I've got OCD. So, all right, time to render. So let's have a look at our render settings. Like I said, I flipped over to physical. It's on adaptive. I'm going to put automatic and make the error threshold 15%. You've seen me do this a million times. So let's just do that and hit the render button. Yeah, before I render, I'm actually going to render to the picture viewer. And that's because, like I said, with the PBR workflow, if you're using standard or physical, you're going to get increased render times. Okay, because of the nature of a reflective sort of material workflow here. An upshot of that is you're going to get sort of global illumination for free. You don't have to turn it on in the render settings. And that's because we're dealing with real reflections here. And because of that, the render times are going to increase in the physical render. So instead of rendering to this, where I don't actually know the resolution, you know, in the viewport here, I'm actually going to render to the picture viewer. So let's go to our output. And I'm going to lock the ratio and actually lower the resolution of the picture, just so it keeps it a bit more zippy for you guys. So now I can render to the picture viewer at this resolution, and it shouldn't take as long as rendering to this here. Okay, so let's just do it. Let's render to the picture viewer. Okay, so first things first, notice how we're getting global illumination, even though it's not turned on in the render settings. Like I said, it's because of the reflective material workflow. It's a natural result of this type of workflow. Also notice how we have lots of grain in our image too. But we can actually clean this grain up. Okay, so it's taking its sweet time. What I might do when I re-render is actually speed up the footage for you guys. So don't think my... You know, I'll do it once at normal speed, but next time I render, I'll speed it up so you guys don't have to watch this every time. Okay, so if we look at the bottom here, you can see the time. It took about 1 minute 9 seconds, and this is the result we're getting. So for that amount of time, if you were using a normal workflow with GI, it'd probably render a lot faster in a scene like this, and it wouldn't look as crap. So you'll notice we're getting lots and lots of noise in this. Like I said, we can actually clean this up. Because our materials are now reflectance based, we need to go into the physical render settings and increase our blurriness subdivision. So let's do that. Let's go into our physical settings, and it's this setting here that is going to affect this noise. So this blurriness subdivision max. I'm going to crank this up to 5. And let's give this another render and see what kind of result we're going to get. Okay, our render is done. Notice how the image is a lot cleaner, but our render times have gone through the roof. And if we look at the bottom down here, we've got 7 minutes 32 seconds. And, you know, that is a long, long time. And especially when you consider that I lowered the resolution of this image to 800 by 4, I forgot what it was now, 450, something like that. So it's not exactly a high resolution image. And taken into consideration that I've got a Ryzen Threadripper 1950X, which is 32 logical processors. So it's no slouch. You know, if you were to do this on, say, a quad core, you're going to be looking at even more time here. So this may not be the way you want to go if you're wanting to use physical or standard render. You may want to just go with a normal workflow and not a PBR one. Now, there are actually ways to reduce the render time by messing around with the samples and stuff if you want a PBR workflow with physical render or standard. But I'm not going to go into that here. I actually might do another tutorial covering that topic. So I just wanted to demonstrate that a PBR workflow can be done with standard and physical render, but may not be the best choice. Which brings me to the new render solution in Cinema 4D R19 ProRender. So let's switch over to that. So I'm physical at the moment. Let's go to ProRender. As normal, we have output, which I'm sure you're all familiar with, and we have save as well. And then we have this ProRender section here. Inside ProRender, you'll find that we have 3 tabs. We've got offline, which is where all our settings for rendering to the picture viewer are. We've got the preview tab, which deals with all the settings for the interactive preview mode, and general contains general settings for ProRender. Let's go over the general settings first. Okay, so we've got default light. This is just an internal light source that is used if there are no lights in your scene. As soon as you create a light source, the internal light source is disregarded. Then we've got static noise. Just leave this turned off. It basically keeps the same noise from frame to frame. So if you're doing an animation, each frame will have the same noise distribution, and it looks really, really unnatural. I honestly don't know why this is even an option as a checkbox. I can't think of a use case for that. But for still images, that's fine if you wanted the same, noise distribution. But like I said, for animation, it looks terrible. A real life camera, when you're shooting through a real life camera, the noise distribution will change from frame to frame, so therefore more natural. Okay, so ray epsilon. This is a bit of a difficult one to explain, so I'm actually going to pull up the help on this one. And this is this is an example of a problem you might find yourself getting. Okay, you may be getting results like this. It kind of looks like shadow acne you get in game engines. This is part of the reason that scale is so important. If you're seeing this, you can slowly increase or lower the ray epsilon until these artifacts are gone. And you can do that using this here. They've got it set to, it's in millimeters by the way, they've got it set to 1. So if you were to, I don't know, let's come out the camera for a minute and zoom into this. If you were looking at a cube on the floor here next to this object and it was this big and you're getting dodgy results like in that image, it's probably because of this. You probably want to lower the ray epsilon and it will sort out your problem. Similarly, if you were to zoom out like this and you were rendering a mountain or something like that, it may be the case that this needs to be increased to get rid of this kind of artifacting. Okay, so devices. We've got override global device settings. So if we twirl down offline devices and preview devices, this is basically the devices, your hardware that's going to be used for the offline mode. So when you render into the picture viewer or, pressing the render button. And then we've got the preview devices, which is the devices, the hardware it's going to be using for when you've got the interactive preview window running. And I usually check this box because by default you can see that it's got one of my GTX 970s selected, but not the other one. So I want to use both. So let's just check them both on. And now we'll be using both. Let's just zoom back into my scene as well, so we're not a million miles away. So yeah, like I said, I'm using both of my graphics cards for the preview window and the offline rendering as well now. We've also got this UCPU for offline and UCPU for preview. So if I click this on, you can see that now my graphics cards are grayed out. So you can't use the CPU and your graphics cards in conjunction with each other at the moment anyway. But I'm going to turn this CPU option off because I've got 2 graphics cards and this is actually an experimental at the moment. It's not been fully realised. Onto the other tabs. you'll notice that both these tabs actually share a lot of the same settings with a few exceptions. So if you look at preview mode, we've got render mode and ray depth and all that kind of thing. And if we look at offline, we've got, you know, render mode, ray depth. But there are some differences between these two. So let's go over the preview tab first and what this actually is and what it does. So to get an idea of what these do, let's actually fire up our interactive preview. So I'm going to get back into my camera. I'm going to leave all the settings at default for the time being. And what I might even do is actually attach this to my window here. And then we can move this up. And then we've got our render settings open at all times. Also as well, you can see very, very slightly, I don't know if you guys can see that on the video, but you can see the sort of edges of what will actually be rendered. I'm actually going to go to options, configure, and just pull this back out again and go to view, and you can see this tinted border and the opacity is at 10. I'm going to crank this up to 90%. In fact, I might do 100, because then we'll be able to see exactly what portion of our thing's rendering, and also we get some information come up that will be in this black area, and it'll be easier to see. So you'll see what I'm saying when I actually start the interactive render view. So the interactive render view can actually be turned on via the menu at the top of the viewport. So if I go up here, you can see this ProRender menu, and if I click this down, we've got this Start ProRender. So let's just start it, and straight away we're getting results. And at the bottom you can see this information here, which is why I made this black, so we could see this. And we've also got a button here saying Start ProRender. As you can see, it's orange. If I click that, it will turn it off. So now we've activated it up here in the menu, I can actually turn it on and off from down here. And you can also change the quality to offline or preview, but I'm going to keep it on preview because that's the whole point of this window, really. Okay, this is pretty important to note. If this is the first time you're using ProRender, you'll probably be looking at a black screen. Do not panic. Nothing is wrong. Okay? So the first time that you actually fire up ProRender, it has to compile shaders. It only has to do this once, and once it's done, you won't have to do it again, unless you update your graphics card, that is, and then it'll have to compile shaders the next time you run ProRender. So what happens is, if I go to my Edit Preferences and bring this up and open Preferences, it didn't happen to me, obviously, because this isn't the first time that I've used ProRender, and I haven't had to update my graphics card recently. But what happens is, if I open the Preferences folder and we actually have a look at this, you'll see that we've got two folders here called GPU Renderer, and I think there's a note in there, yeah, and then there's another one here, and you can see that it's got all these bin files in there. That's what it needs to go compile to make sure that for your graphics card it's doing the right thing when it comes to sampling, tone mapping, ray casting, all of that stuff. So it needs to do that. So if you're looking at a black screen, that's what it's doing. Don't panic. Once it's done, the next time you start ProRender, so I'll just turn that off and then turn it back on again, it will be like this. It will be quick. Okay, so I want to show you the interactive nature of this window. So let's come out of our camera for a minute. And so go back to our objects up here, and I'm just going to come out the camera and look at that. Already you can see the interactive, you can see the purpose of having this interactive window, because it means that you can go, oh, I'm through a wall, I think. Yeah, there we are. So I can zoom in on this and change the view, and it will update immediately and then progressively get better and better. So as ProRender iterates, the image quality gets better and better as it goes along. Every time you move, it has to start the render again and goes through a load of iterations. So there we go. The upshot of this is we can very quickly get feedback when adjusting lights or materials. There's no more back and forth, tweaking, then re-rendering, then tweaking again, then re-rendering again. We get immediate feedback. So let's just demonstrate that. Let's go back to our camera and let's choose our, I didn't name this light, so let's just name this left light. Okay, so we know what we're dealing with. and this one can be called right light because it's on the right hand side. Okay, cool. So if I select our top light here, and I'm just going to pull this out, I can actually mess with the intensity of the that light, and it'll update. So there we go. That's the result of me dropping it all the way down to 0. And if I put it back to 30, we can see we get immediate results. The same is true for the materials as well. So if I take our green material here, and then I fancy changing its colour to something like a orange or something like that. That's more like a disgusting brown, but let's put that up. Immediately we get feedback, we get an update in the viewport. So that's a really good way to author your materials and your lighting before you move on to using these offline settings to do a proper render. So that's the advantage of having this interactive window. Okay, back to these preview settings then. Render mode. So let's have a look at this. Render mode. Here we can select 3 different types of render mode. We have global illumination, which is what we're on at the moment. This mode is probably going to be the one you use the most. This mode includes GI, shadows, reflections, refractions, and transparency. This is basically everything's turned on. Okay, so the next option, we have direct illumination without shadows. So if we look at the picture here, we can see the difference between global illumination and this option. So what does this involve? This option is no GI, no shadows. This is just direct light. This is probably good for setting up lights, maybe just to make sure that the intensity is okay. Who knows? But yeah, you can see the stark contrast between this and the first global illumination mode. Okay, next we have ambient occlusion. So let's turn that on. And there you go. It pretty much does what it says on the tin. It renders an ambient occlusion pass that can be composited over the normal render in post. And as you see, once we've got the ambient occlusion selected, this ambient occlusion ray length is no longer grayed out. If I go back to direct illumination, you can see it's grayed out here. But yeah, on ambient occlusion, this is now active, and now I can change the ray length. So just take a look at this picture, our image here, and you can see what the ambient occlusion looks like at 1 meter or 100 centimeters. But if I drop this down to say 50, it kind of reins it. Let's get more extreme than that. Let's go back to 100, and then just let's knock a 0 off of it and see the difference. There you go. It's a lot tighter now. The ambient occlusion doesn't travel as far, and that's basically what that does. So let's just get that back to default. I'm going to change this back to our global illumination. Okay, depth of field is the next option we've got here, this little checkbox. This just enables and disables depth of field and is controlled in much the same way as the physical render through the camera settings. So let's demonstrate that. If I turn depth of field on, not a lot happens, and that's because our cameras have physical settings, so like our ISO and all that kind of stuff. So whether we get depth of field or not is going to be determined by a camera. So what I'm going to do is come out of my come out of my camera, and I'm actually just going to set up a view. Oh, I've gone through the wall. Brilliant. Let's get back in. There we go. Okay, so I'm going to set up a camera where this ball is. So I'm just going to get that in my view. Let's make sure we get some of the background elements in there. Okay, that should do us. And I'm going to create a new camera. Okay, and let's actually get into this camera so we're looking through it. And pull that out, and then I'm just going to put that there for now. Okay, so we need to know where our focal plane is first. So I'm going to actually use this picker to pick this object. And as you can see, our focal distance is 97 centimeters. And if I go into the physical tab now and actually change our f-stop, let's lower it. We should get some depth of field effects. So let's lower this to 1.5 and see what kind of result we get. And already you can see that the background's blurred out, whereas this ball that we picked a minute ago is in focus. The background elements are, you know, getting blurred. So let's make this more extreme. Let's go to an unrealistic level and say 0.5. And again, our ball's largely in focus, but everything in the background is nice and blurry. So we're getting that depth of field effect. Okay, so let's go back to our settings again. And as you can see, we've got the depth of field, and if we turn this off, obviously it turns off our depth of field effect. And that's basically what it does. So I'm going to get rid of this camera. Let's delete it and go back to our regular one, the one we had set up initially. And let's have a look at the next lot of settings. Okay, so next on our list we've got ray depth here. Ray depth, this is effectively the number of times light bounces, but it also has an effect on transparent objects too. So let's make a transparent material and apply it to an object in our scene. So I'm going to create a new PBR material. I'm just going to call this glass, something like that. And I'm also going to delete the diffuse layer because we're not going to need that. And I'm going to check on the transparency channel. Now you notice that once we've clicked on the transparency channel and go back to reflectance, we've got this transparency in here, the type's Beckman, and that is correct. That needs to be in there. That's absolutely fine. But if you look at our little preview image of our material, it's completely see-through. You know, we've got some specular highlights on there, but that's about it. So we need to go into our transparency and choose our refraction, which you can enter via numbers here, or we can choose a preset. I'm going to choose a preset. There's one for glass already. Where is it? There it is, glass. So now you can see that this looks a lot more realistic. So let's just bung this material. I'm going to delete the material on our big sphere. So let's get rid of that. So now you can see it's gone back to its default grey. And let's get the glass on there. Okay, so largely that's okay, but I just want to talk about this ray depth in a little bit more detail and how it pertains to transparency as well. So let's put this all the way down. Let's as low as it can go. Right, so here we go. It's at level 1 now, and you can see exactly what's going on. At level 1, there's no reflection, no refraction will take place, and no global illumination will occur. Objects are directly lit. Okay, so you know, a ray from the light will fire out and it has one bounce. It will bounce off the floor and into the camera lens so we can see you know, what's going on, and that's evident of the fact that here is completely pitch black, and obviously there's no internal refraction here or reflection. It's just hitting it and then into the camera lens. So that's one bounce. 2, light is bounced once, okay, before getting to the camera. So let's put this up to 2. And already you can see the difference. We're getting a lot, instead of this being pitch black in here, we're getting a little bit more definition because there's a bounce inside there. And this glass is looking a little bit healthier, but not by much. So let's go to 3, which is what this was on initially. Light is reflected twice. Transparent objects are in fact transparent and produce caustics. Now, if you don't know what a caustic is, I'm going to come out of the camera again and just zoom round to this side of our image, and let's have a... Oh, I'm through the wall again. I'm through the wall again. Zoom in. Jesus Christ, where are we? Let's choose our big sphere and center in on that. There we go. Okay, so if I just select this render, there we go. This is a good example of caustics. This is where light will be sort of projected almost through a transparent object like this onto the floor. Obviously it's looking a bit grainy, and we're going to come to that in a minute. But at level 3, you can see that this is a transparent object. So let's get back to our camera view. And obviously by turning this up, this ray depth, it adds another bounce to this computation. And then we've got 5, and so on and so on. The difference in values, the difference in the values of 1, 2, and 3 is very noticeable, while differences at high levels have less of an effect. So going past a value of 12 is pretty pointless, to be honest, as after the 12th bounce, the light rays will have lost so much energy that the difference between, say, 12 and 13 is hardly going to be perceivable. So let's test that theory and crank this up to 12. Okay, so there's 12. And obviously our render times are going to increase because each iteration is going to take longer because it it has to bounce a ray several times, or 12 times. But so that's the kind of result we're getting with 12. So let's crank this up to 14. There's literally no difference between these. So I'd say 12 is the highest level. And I think Cinema 4D actually recommend this as well. I'm going to put the ray depth back to what it is by default, which is 3. You want it at about 3, especially for the preview settings, because the whole point of the preview window is so that it's interactive, you can move about and get a result very, very quickly. And obviously, the higher this ray depth, the more it's going to contribute to a longer sort of, render time. And you don't want that for the interactive mode. Okay, just another note about this ray depth going over 12. If you look at the offline mode, by default it's at 12. So even sort of max on themselves, that's, they're recommended, if you like. Okay, back to preview tab. We've already covered the ambient occlusion ray length when we did this. So onto anti-aliasing samples. Okay, this is pretty straightforward. It basically smooths out samples to reduce what is known as stepping. So I'm going to demonstrate this. I'm going to come out of my camera again, and I'm going to try and find a region of this image that will probably suffer from stepping. Okay. In fact, because I'm recording this video on my GPU and the GPU is being used to render, I'm actually going to save this here. Just so if I have a crash, I can reload the scene and we'll be all good. Okay, so I'm actually going to change the material on this box so that it's a lot more evident. So let's delete this for now and put a red material on it. In fact, I think it was a lot more visible when this was off. Yeah, there we go. So let's just let this figure out. Now, I don't know how well you guys can see this, but if you look at this edge of the box, you can see these steps in it. There's a step there, there's a step there, and a step there. And this is what essentially, and you can see it along this line here as well, at where this area of high contrast is. And what essentially anti-aliasing does, it basically smooths out samples to reduce this stepping effect. So we can see that stepping effect here. Let's crank it up to 1. And already you can see that that's being sorted out rather nicely there. And along this line here, looks a lot smoother. Great. And obviously you can crank it up again to 2 to make it even smoother, and 3, and so on. Now, again, because this is the preview window, every time you increase this anti-aliasing setting up, it will increase how long that an iteration takes. So it will take longer for this image to get cleaner and nicer. And again, we're in preview mode. We probably don't want that. So I usually leave this at 0 because this really doesn't matter while you're working, sorting out materials and your lighting. Okay, next on our list is filter and filter size. You can see that they're grayed out at the moment, and that's because this value is on 0. So if I put it on 1, these become available. So this relates to the anti-aliasing samples and what kind of filter that they're processed through. I tend to leave these alone, but if you're interested, there is plenty of information in the C4D documentation. You can just right click on one of these and say, I'd like to go to help, and then it will show you exactly, what the filter size does and what kind of filter you can use. To be honest, I can't see a lot of difference between the, actually this looks like a lot smoother than this. It looks very sharp on the edges. So take a look at that if you're interested in that. I tend to leave it alone personally, and especially in the preview mode, because I usually have this at 0, which makes these this filter unavailable anyway. Okay, so I'm going to get my red material back on this box and go back to not the red material, sorry, it was this blue material, wasn't it? Yep. And go back to our camera view and move on to our next setting. So our next setting is this radiance clamp. This setting can be used to restrict the brightness of reflective or refracted samples. So I'm going to actually stop this for a moment and save the scene. And let's close that and open up another copy of this scene. Okay, so I can actually demonstrate this quite well using a metal material. So let's just create a PBR material. We're not going to need this diffuse. We'll remove that, and this reflective material, I'm going to change it to a conductor, and let's make this, I don't know, chrome or something like that. Chrome. We got chromium? Yeah. Okay, something like that. That'll do. And we'll put that on our box here. And I'm also going to bring the roughness down so it's very shiny, like so. So again, let's go to ProRender, and then we can kick ProRender off. There we go. And we're going to need a light, so PBR light. Here we go. So this should demonstrate rather well, I'm hoping, what I'm actually talking about. So the radiance clamp setting, like I said, it can be used to restrict the brightness of reflected or refracted samples. Smaller values mean more restriction. Okay, so let's get to our preview mode and have a look at this. So like I said, smaller values even mean more restriction. Higher values allow more brightness. So let's put this at a very low. Let's put this at 2, okay, and see what we're getting. So you can see that there are a few rogue sort of bright pixels here. And obviously, you know, if you add higher iterations, these can be eliminated. But at a low value like this, you're getting, you know, low value of 2, you'll get in this amount. By default it's 10, but I'm going to crank it up to say something like 50. And now let's see what we get. We're getting a lot more of these reflected samples. In fact, we could put this up to 100 and see if we can force it. In fact, we could just turn off the radiance clamp altogether and see what we get. So you're getting a lot more of these sort of bright pixels. So it actually clamps the rays, but only coming from reflected or refracted surfaces. You can see, you know, these bright pixels. So this is what this radiance clamp does. So let's just put that back to default. In fact, let's get back to our other scene. Let's close that. Okay, just to speed things up, I'm going to take this transparent material off of our ball now and put the red one back on, just to keep things nice and zippy. And we're going to be moving on to the next setting in our list. We're onto the progressive rendering section now, and this is where a lot of this noise and all that kind of stuff can be sorted out. So in the progressive rendering section, we have something called a stop condition. So this is where we can set sort of conditions and criteria for how iterations are handled. So what actually defines an iteration? Okay, an iteration has occurred when each pixel on screen has been calculated once. ProRender then moves on to a following iteration and so on. With each iteration, the image quality is improved. So, and we can actually see that. So if I move the camera, you can see ProRender iteration, and you can see it going up. So it's done 50 out of 100, now 70, now 80, now 90, 100. So it's completed. And it gives you the progress here and some other information. But that's what an iteration is. It figures out every single pixel on screen at that time once, then moves on to the next iteration, so iteration 2, and then does the same thing again. And obviously, as iterations go along, the image quality gets better. So let's go back to our camera. So let's look at how we can define how many iterations occur with a stop condition. So the first stop condition is iteration count, and underneath you'll see iteration count. And if I don't know, again, move our camera again, go in and out, this will kick off again, and you can see that we've got our iteration count set to 100, and this is working through the iterations until it gets to 100. So I could actually define this as something else. If I wanted this image quality to get better, I could say, okay, well, let's have this at 500 then. And now you can see that it started again and it's working through the iterations. But this time, instead of stopping at 100, its stop condition will be 500. So I'm actually going to speed this up. So there you have it. We've got to 500. It's a shame they don't give you a time in the preview mode, because it'd be nice to know how long that took. I don't know why they haven't done that, but when you do render to the offline mode, you do get what you normally get in, say, like physical render. You get the time down the bottom here, but strangely not here. So yeah, this is the result of 500 instead of 100, and it's plain to see that, you know, the noise is a lot less. I mean, there's noise there still, but it's a lot less than it was at 100 iterations. Okay, so let's have a look at the next one. We've got time limit. So instead of doing it by iteration count and sort of saying, oh yeah, iteration count here, we can do it via a time limit. So you could say, I don't know, if you had an animation and you had a deadline, you could say, well, how long have I got to render each frame? So you can change that here. At current, it sets to 60 seconds. So let's lower this to something like 10 seconds. And you can see, again, we've got iterations going up. And in 10 seconds, we managed to complete 104 iterations. So that's not bad. So you know, say you went, I've got enough time to have 30 seconds of frame. You could actually denote that and say, okay, the time limit for each frame is 30 seconds. So if this was an animation you were rendering out to the offline mode, it would iterate for 30 seconds and then move on to the next frame. Okay, and the other option, we've got never. So if we turn never on, I mean, it's self-explanatory, really. It never stops iterating. It just goes on and on and on and on and on. So I'm going to leave this for a little bit, but I'll speed up the footage and I'll come back in a sec. Okay, I'm back, and you know, it's still going. We're up to 1,500 samples now, iterations even, and you know, a lot of this noise is being cleaned up rather nicely. You can still see we've got some stepping here and along this here, and that's obviously because I've got the anti-aliasing samples as 0. I can't see a use case for having this on never, unless you're just trying to get an idea of what the final thing will look like, maybe. But again, seeing as this is the sort of preview window, I tend to keep it at iteration count of this and leave it around 100, maybe 200, something like that, just because I'm just trying to get an idea for, you know, what the lighting looks like and the materials, basically. Okay, so moving on, we have preview resolution. Okay. The minimum resolution value defines the resolution to be used during navigation, and the max resolution defines the resolution when the viewport is at rest. Okay, so 1 shows the original resolution. Half merges 4 pixels into 1. A quarter combines 16 pixels, and so on. So let's have a look at these one at a time. Like I said, I was going to put this back down to 100 iterations. So if we come out of our camera, when we move, you can see that when we're actually in motion, you can see that this picture has a resolution. And if you look at the settings here, you can see that this minimum resolution is 1/8. Okay, so let's actually drop this down to let's make it 1/16. And now you can see that the resolution is a lot lower when we move. And if I was to actually crank this up to half, you can see that when we move, the resolution's a lot higher. I tend to keep this at its default setting because when you're moving, especially with the interactive window, you're really not going to need to see, you can see, like this ball. I've got a basic idea of where it is and what's happening. So, at this level, it's okay. Even at 1/16, I still know where those balls are. I've got an idea of what's going on. I'm going to leave it as default, 1/8. That's absolutely fine. So max resolution. So this is the resolution when the camera is at rest. So if I go back to my camera view now, a resolution of 1 is the original resolution. Now I can half that, and you can see that the quality's got a little bit worse there. It's like a low, really low quality photo or something. And if I go, oh, wrong one. If I go even lower, so what, 1/4, that's looking like a 32-bit game from the 90s, 16-bit game even, and even lower. So this will be what it looks like at rest, and even lower. I don't know why you'd want that. It'd be good for creating an image that's, you know, pixelated or something like that, but I'm going to leave it at its 1. So this is what this does. So if your viewport is a bit sluggish or whatever, you can lower this for when you move, and even this if you wanted to. So that's what that does. Okay, default texture resolution. This is a bit of an important one actually. For the preview, its default is set at 128 by 128, so this is a texture size. And you're thinking, texture size? Are you talking about the texture size of all my textures? That's not what this is at all. Let's get rid of this glass material. We don't need it anymore. And create a new PBR material. And I'm just going to call this wood. And now I'm going to explain exactly what's going on here. This setting deals with a current limitation of ProRender. Some of Cinema 4D shaders can't be rendered on the graphics cards, especially things like 3D shaders, that kind of thing. So they need to be converted to bitmaps before the GPU can render them. This determines the resolution of these converted bitmaps, pretty much. So let's demonstrate this. I've made this thing called wood. I'm going to go into my reflectance channel, and in the default diffuse, I'm going to actually drop something in the texture channel. So if I go down to something like surfaces and choose wood here, we get this. Now this is usually, you know, this is something that's sort of internally built by Cinema 4D and is actually a shader in itself. So there's no way for the GPU to read this, so it has to convert it into a bitmap. So let's get this on an object. Let's put it on our sphere here, because it's usually our victim. And I'm going to come out the camera and actually zoom into this bad boy. There wasn't a massive delay, but what it has to do is bake this into a texture in the background, and then it can be used. Okay, so the texture size is 128 at the moment. And if I change this, let's bring it down to something like really low. Let's say 16 by 16. You'll notice that the render hasn't kicked off again. It's just, it's done nothing. So let's give it a kick up the arse. If I stop ProRender and then start it again, we're getting the same result. So maybe we have to, let's give it a kick in the arse by going into our wood and, I don't know, changing the scale. There we go. So now you can see that at a resolution of 16, this has got no detail whatsoever. It's very blurred. And if we put this back up to 128, I think that's what it was anyway. Let me just check. Come here. Yeah, 128, great. And then give this another kick in the arse by saying reset to default. You can see that we're getting a little bit more definition now. So let's boot this up to say like a 1K texture. So 1024 by, actually let's make this really extreme. Not really extreme, but 2048 by 2048. And then we'll give this a kick in the arse again. Reset to default. And you can see that it's having a right old think about it, because it's having to bake down that high resolution texture. But now it's started, we're getting a lot more detail in this shader. So that is basically what this is doing. This is determining the default texture resolution for shaders that need to be turned into actual textures. So let's get rid of our wood. So we're back to where we were. Okay, so now we can move on to the offline tab. Let's get back to our camera view. These settings here in the offline tab are for when you have finished rendering, finished setting up your scene and lighting using the preview window, and now you want to render to the picture viewer itself. A lot of these settings are the same as the preview tab, so we don't need to go over those ones again. I'll just be going over the ones that that actually differ. So let's close this so we've got a full screen and actually pull this out a little bit. Get our render settings up like this. Okay, cool. So this is the offline tab. What have we got in here then? Well, we've got a render mode exactly like the preview. So we've got global illumination, direct illumination, and ambient occlusion in the preview, and we've got exactly the same in here. Depth of field we've already covered. Ray depth, again, we've gone over that in here. Just notice that it's got a ray depth of 12. Anti-aliasing samples, by default they're set to 3, whereas this is 0 by default. So that makes sense. And again, the filter relates to the anti-aliasing samples. Radiance clamp, that's exactly the same. But we've got something new here called the Firefly filter, and we've got the Firefly threshold. So let's actually talk about those for a sec. The Firefly filter restricts fireflies, also known as hot pixels. Fireflies are individual pixels that are very, very bright and stand out when compared to their neighbouring pixels. So I've got an image somewhere that I'll open up, which is a good example of this. Okay, so we've got an image here, and you can see these hot spots here, these hot pixels here, and what the Firefly filter does is try and eliminate them, so you're getting something a bit more like this via a post effect. These fireflies can actually be eliminated by increasing the amount of iterations that you do, but the drawback of doing it like this is that when nearly all of your image is at an acceptable quality, you are increasing your render times for the sake of getting rid of these pixels. So in a bid to sort of do a more efficient way of getting rid of them, this Firefly filter comes in to remove these hotspots. So just to explain, the checkbox turns it on and off, great, and the Firefly threshold determines how bright a pixel has to be compared to its neighbours before it's eliminated. Okay, so the larger this value is, the greater the difference can be without the pixel being adapted to its surrounding pixels before the hotspot's eliminated. Smaller values will result in fewer fireflies, but too small a value can produce spotty results. So, you know, there might be, if you've got a really, really small value and then you've got, say, like a bright reflection, say, of a window, you could start blurring the edges of it or even create spotty effects. So you don't want to go too low. So it's a little bit of a balancing act. So if you do see hot spots in your image, that's what this does. It's a much better solution than, you know, just cranking up your iterations. Okay, on to the next section, which is this sort of level of detail. We've got some render HUD options and stuff. I don't really want to dwell on these options for too long, as these are normal C4D settings that are either included in the render or not. So, for example, if I do a render to the picture viewer or whatever, if I hit the render button, I can choose whether this render HUD, so all this information, is actually included in the render or not. Same with the doodle, display the LOD and all that kind of stuff. So it's basically, you know, just check boxes for options in your render. Okay, let's get on to the main event here, the progressive rendering section, just like we had in the preview. The stop conditions here are almost identical to what we have in our preview tab, with a few exceptions. So let's have a look at this. We've got iteration count, just like we did in the preview, time limit, just like we did in the preview, and we've got never, just like we had in the preview. But there is an exception in never. The never stop condition, which is present in both tabs, has the addition of an iteration limit. So if you change this to never and then I hit render, it will literally go forever, which is what the preview one does. So if I turn this to never, it will just keep iterating forever. But if I go into the offline mode, we've got an iteration count limit. So even if I set this to never, I can say, yeah, just keep iterating until the cows come home. But, you know, maybe when you get to 16 million iterations, that'll be enough. You know, so you can set a count limit, an iteration count limit, which is baffling really, because that's essentially what the iteration count is. If I go back to iteration count, I could just set this to 16 million iterations. So bit baffling there. Now the other difference we also have an extra stop condition called the threshold, which is here, which is essentially a quality threshold, kind of like you get on the physical render. Low values mean less noise and longer render times, and high values produce more noise but lower render times. Very small values such as 0.01 should be avoided, as the render will just keep going forever. So very low values is a big no-no. Let's demonstrate this. If I go to threshold and say, okay, our threshold is 20%. Let's stop the interactive renderer and actually render to the viewport. So let's kick this off. You can see that it's iterating. It's saying that its progress is at 52, 76, 89. Come on, we can get there. And it's done. So basically it said that when you get to a threshold of quality, you know, like kind of like the error threshold, 20%, you stop. Now if I put this back down to its default and render, I'm just going to make sure, yeah, I have, and then render again, it will keep iterating until it gets down to this error threshold. It's saying it's at 50 odd percent, 68, and so on and so on. But the point is that once it reaches this threshold of quality, it will stop rendering, which is quite handy, because if you look at your scene, then render out to a threshold you're happy with, and it's an animation, you can say, right, this is an acceptable level of noise or error, if you like. But when it gets to that, you move on to the next frame. So yeah, very, very handy. And it makes sense why this isn't present in the preview, because, you know, for various reasons. Okay, so let me quit out of this. The next thing we've got on our list is bucket rendering. I'm gonna change this back to an iteration count of 100, just so it's nice and quick. And actually, sorry, it's not bucket rendering. The next thing on our list is refresh rendering interval. So onto the refresh mode, the image can be updated in the picture viewer after each iteration, but this is not recommended because this is a computationally intensive process. So here we can define the number of iterations before an update occurs. So I'm just going to just kick off a render and you'll see what I mean. Okay, so we've got iterations 10 and it updated the viewport here. 30, it updated again, and here you can see when it'll update. It says here next update after how many iterations. So it counts down 7, 5, 4, 3, 2, 1, then it updates. If you had it update in every frame, in fact we can do that if you want. So we've got this we've got this iteration interval. We can change this to 1. So every 1 frames it updates. So let's render again. Update, 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 update. It's updating every frame. But what is the point of that when you're doing a final render and that takes computational power away from the actual rendering itself? So by default, this is actually set to 10, I think. But I'm going to actually crank it up to, I don't know, 25, and then render again. So there's our first iteration. It waits till it gets to 25 iterations here. Boom, next update. And then does another 25 frames. Boom, next update. Okay, so you get the point of that. And to be honest, if I was doing a final render, I'd set this iteration interval to something like, I don't know, 60 iterations, something like that. But I'm going to return this back to normal, which is 10, and look at another option we have. So we've got we've got time interval in seconds. So basically, instead of saying when I get to 10 iterations I'll update, you do it in seconds. So you can say when I get to 10 seconds I'll update. So let's just have a look at that. There's our first iteration. It waits until it gets to 10 seconds. This iteration count doesn't matter anymore. It's all about time. Dun, 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 dun. 10 seconds is long. There you go. So we got to 10 seconds and it updated. So you can do it either one or two ways, via iterations or by the time interval. And again, we've got, so actually onto bucket rendering now. So when I render out to the picture viewer, sorry, just making everything at default. When I render out to the picture viewer, we get this kind of thing. It renders the entire image every You know, it tries to go through doing every single pixel on screen at the same time. But if you wanted to, you could have bucket rendering just like you get in the physical render. So let's stop calculating this image and actually just turn on bucket rendering and hit render. Now it is doing it in sections. Now you can see here the bucket width and height is 512 by 512, and seeing as our image size is only 800 by 450, it's no wonder we're getting a result like this. So let's actually change our bucket width and height. Let's change this, and also let's change this so it doesn't do iteration count, because what will happen is for each bucket it'll have to do 100 iterations, then move on to the next bucket. So why don't we change this to threshold and say something like I don't know, 5%, something like that. So let's change our bucket width and height. I'm going to change it to something pretty small, 128 maybe, something like that. And then let's kick it off again. So now we're getting bucket rendering. So that'll iterate right away until this threshold of 5% has been reached, then move on to the next bucket. So you can actually render like that if you so wish. Also, we've got another option here, which is the bucket sequence. So let's just turn this off. At the moment it's set to centered, but we can do it from left to right, right to left, top to bottom, bottom to top. So let's do left to right, just to give you an idea. It's pretty obvious if you ask me. So it'll start in the left top corner. It'll iterate away until it reaches this threshold of 5%. Boom, and then it goes on to the next bucket. So you can really choose how you want this to render out with the bucket sequence. So that's essentially it, guys. We've covered the PBR workflow in general, and we've covered ProRender. There is a little bit more to the PBR sort of workflow when working specifically with the physical render and standard renderer, but I think I'm going to go into that, how to sort of optimize that in another tutorial. As always, guys, thanks for listening. Don't forget to check out the Digital Meat website at digitalmeat.uk. There you can vote for upcoming tutorials and become a member and comment on videos and all that kind of stuff. So go take a look at that. You can follow me on social media at Facebook, Twitter, and Google+. There'll be links in the description. And if you'd like to support Digital Meat and get some extra content while you're at it, there's my Patreon page. It's $1 a month to be a Patreon, so go check that out. There'll be a link on screen after the video. Thanks for listening, guys. Bye.